Hey, so what happened when the past, the present, and the future all walked into the same room? It got tense. The past, present, and future, those are three different tenses. Okay, we'll move on. We'll move on. Okay, this is a lesson about common types of forces, and by the end of this lesson, you will be able to identify the most common forces in classical physics and describe them using abbreviations. So classical physics, that's the physics of everyday life, if you will. And a lot of what you're doing are analyzing forces acting on objects. And so that's we're just going to get familiar with some common forces that you might encounter so they don't seem so strange when we work through interactions of forces. Okay, so first common force to know would be the force of gravity. Notice how we um, notice the way that we represent forces. We use a big F, right? A big F means that's just an abbreviation for force. And then we use a subscript. Subscript, that's little something, little letter or letters below. So we say big F, little g if we want to say force of gravity, or sometimes you'll see big F, little grav, or even maybe big F, little gravity. They all mean the same thing. They're just abbreviations for these things. And what is gravity? The force of gravity? Well, it pulls objects towards the center of the earth. And this is also called weight. Your weight is the force of gravity acting on you. And weight is your mass due to the acceleration due to gravity. You might have heard of that. It's called g-force, right? G-force is essentially a measure of your weight. So right now, you are experiencing 1g, but you can, in certain situations, experience more than a g. But everything accelerates towards the center of the Earth with the same at the same rate, and that times your mass gives you your weight. Okay, next force. It's called the normal force, and yet it's one of the ones that we forget about the most. Normal force. What is the normal force? It pushes up from a surface that an object is resting on. So imagine we put this heavy box on this table. Well, gravity is pulling downwards on this box with a force of 80 newtons, but the box isn't moving. It's not moving. That means forces are in balance. And something has to be balancing out that force of gravity or the weight, and that force is called the normal force. So that's actually the force of the table pushing back up on the box with an equal amount. We call that the normal force, and you might abbreviate it with F norm, F normal, something like that. But that's really important. Normal actually means perpendicular to. It's don't worry about the origins of it, and it's a strange word. It's not really normal, but it is a very important force because anytime something is sitting on something else, there's a normal force balancing it out. Another one that's really common is called friction. F frict, F F, F friction. All those are abbreviations for it. And that's two objects trying to slide past each other. So you experience friction all the time. If you didn't, life would be very different. And friction forces vary quite a bit. So, for example, you can see in this goofy cartoon that if you try to slide downwards on your feet on a grassy slope, you'll probably go nowhere. But if you attach waxed skis and you go on something covered in snow, you will probably go very fast because this is a lot of friction. This is very little friction. So friction, that's the resistance of two things sliding past each other. Another really common one is air resistance. Pretty much anything time we move on the surface of Earth, we are experiencing air resistance. Sometimes we abbreviate that with a big F, little air. Sometimes we go big F, drag, or we just call it drag. And drag, that's air sort of pulling backwards against the motion. So, for example, this car, right? It's moving into the left, but the force of air is pushing back against it in the other direction. And one of the reasons you have to get so much force from the car's engine going through the wheels is to resist all of that air resistance. You might know, the wind will produce more air resistance on you, and that maybe you're riding your bike and you have to pedal even harder. You have to put more force into it to resist the air resistance. Here we go with a common one called tension. So tension is anytime we have a cable, a rope, a wire, a string, or something long and thin like that that's being pulled on both ends. You're pulling on a string on both ends. Let's say we are suspending something like an elevator from a cable. We've got a tension force. We might refer to that as big F, little tens. It's not multiples of 10. That's a shorthand for tension, or maybe you'll see tension. But that is pulling on both ends of a cable, rope, wire, string, or other similar item. And then a very common one that you do experience pretty much in everyday life is applied force. And that's anytime you or a person or some object applies a force to something else by pushing, right? So in this example, this guy has to move a refrigerator, so he is going to apply a force in this direction. He's applying it to the refrigerator. So that's applied force. And that's it for our most common forces that you're going to see when we start to analyze forces acting on an object and the resulting motion. All right, see you in the next video.